Hi guys and welcome back. So today we're going to be doing something a little bit different. This is the type of content that's going to be on my new channel, and what we're going to do today is we're going to make a USB interface to allow you to play wirelessly with any transmitter on any simulator you want. Now we are going to be using a couple things. We're going to use Cleric software for the VJoy software that he created, the little plugin for it. And if you missed out, I'll have a link to his GitHub down below. So he has a way to do it through Arduino and through the FTDI breakout, but that one is slower than the Arduino. But the Arduino, you need to, apply a blank script, and then you also need to apply another script for the SBUS part. However, what I want to do today is want to create something completely out of the Arduino. Now, I know the Arduino uses the CH340 IC for a USB to serial converter. Now, I did go ahead and start a schematic through the datasheet, but then I thought that would be a little bit too long, and then I figured out that EasyEDA has one just ready made. So if we click here, we can actually get the schematic. So what we're going to do is we're going to go ahead and take the schematic and then build a PCB to take both SBUS and IBUS. Now, SBUS, we're going to need to invert the signal. Now, if you're using SBUS that's not inverted, then you would go ahead and connect it on the IBUS pad, and we'll understand that step by step. So let's get started. So first of all, as you can see here, here's a schematic for the CH340. So let's go ahead and just grab this guy here, and we're going to start a new schematic. So I'm just going to highlight this and just take it, and I'm going to create a new schematic here. All right, and we're just going to paste it there, and we're going to bring it in. All right. Now let's just let's clean this up just a tiny bit before continuing. All right, so let's take a look at this. So as you can tell here, this is running at 12 megahertz. This is a 12 megahertz crystal. This is the crystal symbol in a schematic, and they're going to the chip here to allow it to run at 12 megahertz to keep it pretty reliable. I don't think it has an inbuilt frequency clock here, so that's why it's using an external crystal, which is running at 12 megahertz. Now we're gonna have to buy every single component here separately, and it's gonna be very simple and straightforward. We're gonna go with just the basic 0805 resistors, sized, and capacitors, because I just bought like this book full of them from Banggood for like 30 bucks. I'll leave a link to that down below. I highly recommend you get one, because I'm going to have more projects on that channel if you're interested in this stuff. I'm not going to dig too far in this tutorial right now, but we're just going to see how to set this up. So here's basically a pre-made schematic that we want to make as a PCB here. So let's get started. Now, first of all, this is going to be the USB here. USB has the ground, UD plus, UD minus, and then the 5 volts. And as you can tell, we have the D plus and the D minus here, and 5 volts is going to 5 volts. Now, anything that's doing this, going to 5 volts, is all connected together. And we'll see that on the PCB, and it'll make more sense. This way, they do this just to make it cleaner, and they call them net labels here, or whatever you want to call them. They call them usually, I think, net labels, if I remember correctly. Yeah, it's a net label, which connects them together, so you don't have to have all these 5 volts connected up here together, which makes it a little bit simple. And this is a sign for ground, and this is a capacitor. C's are usually capacitors, R's are usually resistors, and the number is just to keep reference, so R1, R2, and the system here does that automatically here. Now we're gonna need to add something a bit extra here, and we're gonna have to add an inverter for the SBUS. So let's do that in the schematic here first, and then we're gonna get into the PCB design. All right, so to create the inverter schematic here, to add the inverter part, we're gonna need 3 components. We're gonna need 2 resistors, so let's just bring the 2 resistors in. So I just picked up the resistor from right there. I'm gonna set up a resistor. Let's just move this a little here and just zoom out a little bit. So I'm gonna put 1 resistor, and then here's another resistor. And one of them is going to be 10K, so 10 kilo ohm resistor, and the other one's going to be a 4.7K resistor here. There we go. So we have that set up, and I actually want to switch the orientation. I just clicked on it and press spacebar here. Next thing we need is a transistor. Now we're going to need the BC547B transistor, and what you can do is just insert that there, click search, it'll search for it, and then once it gets it for you, you click on it, place, and we're just going to place this guy right here. All right, so next thing we want to do is we want to go ahead and connect everything here. So let's just do that. We grab this wire tool, and then we're just going to connect this one to there, and then this one to this resistor. So we're good to go. And then now we're going to need to set up a ground, which is going to be down here. Okay, press escape key, and then next thing we need to do is connect the ground here There we go. So now our transistor is almost ready. So this side of the 10K resistor is going to go to 5 volts. So what I'm going to do is I'm just going to take this, I'm going to copy it, and then press paste. There we go. So it just grabs the correct net labels together. Okay, beautiful. So now we have that connected. And this is where our SBUS signal is going to go in. So what I'm going to do here is I'm going to create another wire. And it's going to go up to here. And I'm going to create a net label. Once I escape from this here, there we go. We're going to create a net label. And we're going to call it SBUS. Once we align that little hole, as you can tell now, that's perfect. So we can set it up like this. And we're going to call this SBUS or FR Sky. So because some SBUS is uninverted. So FR Sky SBUS, or just FR Sky. There we go. FR Sky SBUS. Great. We need to create another wire that's coming up from this side, which we're going to do like so. We're just going to grab the wire tool, wait for it to load a little. There we go. And then we're going to right click to end it there. And now we're going to create another label, and we're going to call it RXD, so which is this one here, because we're going to want the FR Sky to go here, go through the resistor, invert the signal, and pop into the RX of the chip here, so we can send it to us via USB, so we can take control of this guy. All right, so let's go ahead and grab this. We're going to apply another label here, and we're just going to go like this, and then we're going to name this RXD. And this will make a little bit more sense as we go. All right, so there we go. It's perfect. Okay, so RXD is going to go here. It's going to pipe through there. That's if you connected your SBUS to here. All right, so the schematic is pretty much done here. Let's go ahead and convert this into a PCB. So we just click create convert to PCB up here. All right, guys, so that's going to include it for the first part of the video. The second part is going to be into the PCB design. I really wanted to make it a separate video because it's going to have a lot more information, and this video is going to be very long for a lot of people to watch. So I thought the best way to do this is to split it into 2 videos, and that's what we're doing here. And well, I really hope you guys learned something in this video. I know I didn't go too much into detail, but I will be going to more detail in later videos. This is just to get the project out there as soon as possible, because I really want to have this made and manufactured and showing you the whole process of me doing it. I really hope you guys learned something today, and if you guys have any questions or any suggestions, feel free to let me know. And don't forget to hit that like button as well as the notification bell icon. That really greatly supports the channel, and I will see you in the next one. Peace out, guys.